in this example, we want to draw the VSEPR for the molecules provided and give the bond angles that are asked. And we'd also like to look at the hybridization of these atoms. So when you're already provided a Lewis dot structure, the question is, where do you begin? So I like to think you want to begin with something kind of in the center. You could choose to begin with either nitrogen or oxygen. I'll start with oxygen. This oxygen has a steric number of 4, 1, 2, 3, 4. So we know that the oxygen is going to have an arrangement that looks something like this. It's a kind of stinky wedge, but that's what we have. So in this case, the question is, where do we want to put our atoms? I tend to like mine in the plane of the paper. So I'll put my hydrogen here, my nitrogen here, and my 2 lone pairs up at the top. Now we have a nitrogen that has a steric number of 1, 2, 3. It has 1, 2, 3. So we know it's going to look something like this. From here, again, the question is, where do we put the electrons and where do we put the lone pairs? So this molecule is going to be planar. So the bond angles that are asked about are this bond angle. This is 1, and then this bond angle is 2. So the bond angle here is 120 degrees. This one is going to be much, much less than 109.5. And so the hybridization for these atoms, we have for the oxygen, we're going to have a sp3. This nitrogen will be sp2, and this oxygen is also sp2. So we can remember that the geometries tell us which hybridization we have. So for our next molecule, it's a little bit bigger, but again, I find it easiest to start to go from the next central atom, which in this case would be carbon. So we have a steric number of 3, which tells us we have a trigonal planar geometry. The question is, what goes where? I kind of like to start mine drawing exactly like we see them here. So I'll put my hydrogen here, my oxygen here, my lone pairs here. From here, we have an oxygen with a steric number of 4. So we can put our oxygen here with our lone pairs coming in and out of the plane of the board. This reaches us to carbon. This carbon has a steric number of 4. So we know that it should look something just a little bit like this. The question is, the hydrogens can go anywhere you like on this molecule. So the question becomes, where are our bond angles? So if this is bond angle 8, this one is going to be 109.5 because it's a tetrahedral molecule. This molecule here is going to, or this bond is 109.5. It's actually much, much less than that. So it's smaller. And here we have 120 degrees. We can look and determine the hybridization of all of these. This, based on our bond angle and the arrangement, we know is going to be an sp3 hybridized. Carbon atom, our oxygen molecule, based on the electron geometries, is also going to be sp3. Our carbon here is going to be sp2. So the geometries both give you the hybridization and the bond angles.